Very good afternoon. My name is Agnel Cheruvathoor, as announced, and I'm very honored to receive this award on behalf of Siemens Energy. And actually, this is not me, right? I mean, this is the company, and I would say that we are honored for the e-fuels, and I would be also talking about that particular project in my slides. So, by the way, I'm heading business development here in India as well as in the Middle East. I'm based out of Dubai. So, when we talk about the hydrogen business, I want to talk directly about the heart of the business. And what does Siemens Energy do? We are into the field of manufacturing electrolyzers. And we also do design and integration of the overall Power-to-X value chain. And this is how our Silyzer 300, this is how the Silyzer 300 looks like. It's a 17.5 megawatt electrolyzer. It's a PEM electrolyzer, which stands for proton exchange membrane. It uses basically pure water, and it produces very, very high quality hydrogen. The only impurities that you see coming out of this product is oxygen, which also can be removed using deoxo dryers. So the hydrogen purity that you get is very, very high. It's about 99.9999% purity. It works at 75.5% efficiency at full load. And it produces, one unit produces about 333 kg per hour. We are actually planning and building electrolyzers for large-scale applications. And that's why our 17.5 megawatt electrolyzer can be used in series and built into subsequently large installations. So you see here that we have one array which is 17.5, but you could also have a customized solution where you can put multiple of these units together and make multi 100 or megawatts or gigawatt scaled plant. We are manufacturing in Berlin. As of today, we have a plant that is already running at 1 gigawatts. So this was in the past where we had our units manufactured in Erlangen in Germany, but now we have shifted to Berlin, where it's a fully automated production facility that produces about 1 gigawatts. And going forward from 2025 onwards, we will be having a manufacturing capacity of 3 gigawatts with 1 gigawatt per year additional as every year rolls by. So this is basically the map of Germany, right? And you see that I already talked about the manufacturing, which is going to be held in Berlin. However, we are only going to be manufacturing the stacks itself in Berlin. The last final manufacturing and packaging is going to be done at our packager unit, which is going to be in Mulheim. And in Erlangen, we have our engineering facilities that is also responsible for research and development of the product. Now, even though this shows the German map, what we can do is that we can set up these kind of facilities anywhere in the world, especially when you look at a large-scale plant. It would always make sense to localize as much as possible. And we would start with the final stage manufacturing and packaging first, and then in case of higher volumes, we would also go into the stack manufacturing itself, wherever the market is. So we We are manufacturing in gigawatt scale, and we are growing in terms of production. We are also growing in terms of the projects that we are doing. And here you see that we have started slowly, but we have been steadily increasing in size. So I would like to point out this 8.5 megawatt unit in Wunsiedel in Germany, where they are using it for the hydrogen, the green hydrogen for industrial applications. This is a fully functioning plant as of today. And our next plant is also in Germany, in a place called Oberhausen, which is basically using our one electrolyzer unit of 17.5 megawatts. And this is with our partner Air Liquide. Going forward, we also have projects that are in the 50 megawatt range and going to 200 megawatt range. So what you see here is that we have about 3 electrolyzers that we are going to supply for the 50 megawatt project in Denmark, and in the 200 megawatt plant in Normandy in France, we are going to supply about 12 of our electrolyzers. So all these projects are in Germany, and there's a reason why it's in Germany, because of various factors which include the cost of the tariffs, the government incentives, etc. However, for us, what we see here is a chance to execute these particular plans. We have been talking about, I was talking to our colleagues here, and I have been personally in this industry for about 4 years. And we are already, in 4 years, we are already veterans of this industry. We feel that this industry is still in its infancy. And there's a lot of lessons that we have to learn. And for us, the important thing is that when we grow the way we are growing steadily, it helps us absorb the lessons learned, not only in our products, but also in our projects, including the offerings of serviceability over the life of the project. As such, with Siemens Energy, we are present all over the world. And you can see these, the purple dots are areas where we are present. And basically what we do is that in case if we have a project which is outside Germany, which we have a few, we can utilize our offices and our services across the world to form either the local manufacturing hubs or the service networks. Okay, so this is a slide that just shows our presence worldwide. So the project reference that I was talking about is this one. This is a project that is based in Chile, in the Patagonia region. And here, we are producing green hydrogen from wind power. And the green hydrogen is in turn used to produce green methanol. And the green methanol is then used to produce green gasoline. And this is for the car mobility sector. And here we have our off-takers, which is Porsche. This plant went operational in the end of last year, and it is already producing about 130,000 liters of e-fuel every year. Going forward, we have plans in 2025 to increase the capacity to about 55 million liters of e-fuel, and going to 2027, we want to even increase it 10 times further. So in this rendering that you see on the slide, you see the electrolyzer facility, you see the direct air capture here, so this is a direct air capture and not carbon capture. You see the water tanks, power control center, you see the hydrogen and carbon dioxide storage, which is combined, the carbon dioxide and hydrogen is combined to produce methanol. And then you see the methanol and the gasoline plant here. Yeah. We also have other projects, like the project that we talked about, the 50 megawatt project called Inkasso in Germany. This uses 3 of our electrolyzers of 17.5 megawatts, of course. And the plant produces 1,000 kg of hydrogen per hour. So this was the first large-scale e-methanol project anywhere in the world. And we have even a larger project, which is a 70 megawatt project with our partner Ørsted, which is going to produce 50 tons of e-methanol per year from 2025 onwards. At least right now, the blueprint is that once we produce one of these plants, the idea would be to produce more and more of these plants going forward. So it comes to my last slide, and I want to talk a little bit about the value chain that we are striving for. So we talked about the electrolyzer stack. Yeah? So today we are manufacturing about 1 gigawatt, and we are going to go up to 3 gigawatt in capacity. We want to make it scalable, but at the same time, we want to make it dependable. Okay? So we strive for quality. And one thing that we have learned is that it is not only the electrolyzer that needs to be focused upon, it's the balance of the plant that also needs to be focused upon. So every component, for example, today, because of the electrolyzer industry, the transformers, the rectifiers, the compression equipment, these have all become high in demand, and it's basically a bottleneck to find in the industry. So what we are trying to do is we are not only trying to grow the electrolyzer itself, we are focusing also on our value chain where we have multiple vendors that we can qualify and approach so that we succeed in these large-scale projects going forward. Another point that I described earlier was also that we are very focused on learning from projects during implementation. Yeah, and this is applicable not only to our product itself, but this is applicable also to project execution and also towards the degradation, for example, yeah, that we obtain through the life of the plant. We talked about value-added networks and supply chain already, and the last topic is the service infrastructure. Since we are located everywhere in the world, it's easier for us to serve our customers. Serviceability is an aspect that is not discussed enough. Yeah? And if you're an off-taker who's taking the risk of developing a plant that is going to run for 20, 25, 30 years, then the dependability of this particular plant over the life becomes very important. And this is where we come in. So with that, I would like to say thank you, and if you have any questions, I will be here. We can connect after the event as well.
I think it's a good idea to open the floor for questions now because the slides are on and what these people have seen is fresh in their memory. So I would like to take the question and answer session soon after each paper presentation, since we have only 5 people today and we are on time. Thank you. Good question.
You could do that as well. However, there are multiple ways to, I would say, skin the cat. Yeah. The approach that we are doing, we are into the field of producing green hydrogen. Yeah. So we have partnered with our partners, in this case Johnson Matthey, to convert the hydrogen to methanol and gasoline. There are other approaches. Yeah. So if there is another project, we could try the other approach as well. But for this particular one, this is the approach we have considered.
I think making methanol is not a bad idea. Are you going to take CO2 from the DAC?
For the smaller unit, it is possible. Okay, as we go larger, you have to think about how to get carbon dioxide from a point source.
Yeah.
And then transport it to the sites. And that becomes a challenge. But this was always a critical path problem that we had identified from the past. So there are some industries that we have identified, sources for carbon dioxide for basically the next phases of the project.
So why not to think of making ammonia? Is that all for local consumption? You're not thinking of exporting ammonia anywhere?
We are involved in projects that are ammonia-centric. So for us, it doesn't matter. You know, there are different derivatives. So if the off-taker is focused on gasoline, like Porsche was for this particular project, we would go for the methanol. We would go for methanol and gasoline. Okay, but we are also focused on ammonia for other projects.
One more question from audience. Yes? Yes, Mr. Anil Razdan. Okay, somebody at the back, I can't hear you.
Sir, for the 17.5 megawatt plant that we have installed, what is the capex and opex and the total life cycle cost that you have
He's asking for 17.5 megawatt, the capex. Those are big plants.
Yeah, so every project is different, right? So every project has different boundary conditions, okay, depending upon where it is located. So for example, there could be a project that is located close to the shore and you would take cooling water right from the... Specifically for this, I could give you a range. A ballpark is fine, yeah? So it would be in the range of, I would say the electrolyzer would be in the range of $600 to $800 per kg, dollar per kilowatt.
Okay.
There's one question here, please.
Dr. Anil Razdan.
Is there a better performance quality of gasoline produced from this route as compared to the normal route? I mean, because you see, why I'm asking this question is that if Porsche is asking for it, it may be giving you some bonus like a French perfume, you see. So.
Okay. There would be other alternatives. For example, you're talking about gasoline, but I will talk about sustainable aviation fuel, for example, okay? For sustainable aviation fuel, one way is to go the methanol route, okay? So you go from methanol to olefins. From olefins, you would go to sustainable aviation fuel or jet fuel, or you could use the Haldor-Topsoe process, okay? Where you use the reverse water gas shift. There are pros and cons to every approach that you take. What you realize is that when you go for a commercial application, there might be bottlenecks at one particular point in the value chain which is not fully demonstrated yet. This, if it is demonstrated, and it is happening right now, so you would see more and more of these projects become commercial as the time goes on. But at the particular time that you are in, when you do the analysis, based on a project that is suitable to go fully commercial, that is the decision we took at that point in time. Yeah, so it is based on sound reasoning when we do look at different aspects, and then we come up with a proper case analysis.
Thank you, Agnel. We have to go to the next speaker. We're running out of time.
Just a minute, I have a question. Yeah, last question.
Because any other question we can...
So,
okay, last question.
I just wanted to ask, like, so you are developing e-fuel, right? So what is the cost difference? Like, how much does e-fuel cost than normal gasoline which is produced?
Gasoline is also e-fuel. So e-fuel could be anything. It could be e-gasoline, it could be e-methanol, it could be e-ammonia.
Like I'm asking that e-gasoline is produced by solar energy, then hydrogen, and then the gasoline is just produced by, that is just produced by crude oil, and then, you know, you burn it in a reformer, then
yes.
How much cost difference does it like?
I can tell you that the e-gasoline will be more expensive, and it's not a surprise, because this is something that we have to come to terms with. The green hydrogen is more expensive than brown hydrogen. It's not a surprise, because today your solar and your wind, it's not so much because of the tariffs, but you do not have the capacity factor, the utilization factors coming into the green hydrogen. And Plus, the plants are small, so you don't have economies of scale today, as of today. So you would expect it to be more expensive. How much more expensive would also depend upon a case-to-case basis.
But if it's,
I think you should have it in the private conversation. I think I leave it there. Next question,
Okay,
please.
okay, okay.
Because we are running out of time.
Yeah, thank you. I have one question related to the efficiency of this whole system that you have done. And why PEM? What exactly is the efficiency of this 17.5 megawatt that you have demonstrated?
For the plant itself, we will have to go and check. Normally, the efficiencies are comparable, okay? So when you compare it with, I don't know whether my friend here would agree, but the efficiencies would be comparable between the PEM and the alkaline technologies. It depends upon whether it is pressurized or atmospheric pressure that it's operating on. The factor that decided here for the PEM is because of the variability of the wind. So it was not really the efficiency, but the variability in the input profile that made a case for the PEM technology.
Which you think is not possible in case of alkaline?
I wouldn't say it is not possible. It is certainly possible, but it would be less efficient. If the power is constantly fluctuating, then if you want to get maximum efficiency out of that plant, out of that setup, then PEM would give you the best alternative. But again, PEM is slightly more expensive than the alkaline. So you have to do a case-by-case analysis each time.
I'll discuss with you.
Thank you. I think I would request people to keep the questions very short, and I want your answer also, Agnel, to be crisp. You tend to be a little bit more verbose, because that's robbing to the time of other 4 more speakers I have here, and they have 1 more session also after this. So if there is any other question now, I'm going to stop here. You can take it during the break.
I have one question. Here.
Who is it?
Yeah. Here. Good afternoon, Mr. Agnel. As you said that the capex cost for a per kilowatt electrolyzer is around 600 to 800. I just want to know that what is the percentage for that membrane cost from this per kilowatt capex you said?
We will have to check on that. I cannot tell you from the top of my head right now.
And any idea like what is the size
No,
of that
not at the
membrane?
moment. We can discuss afterwards, but I cannot tell you from now.
Sure. Thank you.
Okay.
Was that crisp?
Thank you. Anil Razdan, any more? You have? Okay. Thank you very much. Give me a big hand. That was a nice.